Hey guys, a couple of things today, a little bit of geometry, but first, this weird thing that for factoring, it's very interesting. Okay, first off, when conjugates are multiplied, the middle terms, they cancel out. This is weird. Now, what's a conjugate? Here's what a conjugate is. Make sure you know when somebody says conjugate, what we're talking about. A conjugate, when you look at let's say a binomial like this, a conjugate of that is exactly the same two terms except for one thing. The middle, the operational, like if it's a plus here, it'll turn to a minus. If it starts with a minus, it turns into a plus. So that is the conjugate. 2x minus y is the conjugate of 2x plus y. This conjugate, you tell me, what's the conjugate of this? 4x plus 3b. Yep. Okay, now watch what happens when you multiply these things out. 2x times 2x is 4x squared. 2x times negative y is negative 2xy. Done. Y times 2x is positive 2xy. Y times negative y is negative y squared. Okay, but look at what happens here. This cancels. So we have 4x squared minus y squared. Now, don't look, look at that for a second. This circled is the same thing as this. Now, what's the relationship between the 4x squared and 2x? What's the relationship between the y squared and the y? Come back to that in a second. Now, look at this one. Let's do this one. In fact, pause it. You go ahead and do it yourself and come back. Unpause it when you're finished. Come on, let's go. Pause it. All right. Okay, 4x times 4x is 16x squared. 4x times 3b is 12, I don't know, let's call it xb. Done. Negative 3b times 4x is negative 12xb. And then negative 3b times positive 3b is negative 9b squared. Look at this. These two cancel. They're gone. Now we have 16x squared minus 9b squared. Now look at this. Look at this thing and see how it relates to the 4s and the 3s and the x's and the y's. You see what happens here? Look at that. Okay, I'm not going to explicitly say what it is, but we're going to get to that in a second. Okay, now look at this. If you have 16 minus 9, obviously we know the answer is 7, right? Okay, 36 minus 25, 11, of course. 81 minus 49, well, 81 minus 50 is 31. So 81 minus less than that is 32, right? Okay, well, look at this. Look what happens here. Look at what we can do here. We can take the square root of 16 and the square root of 9, right? What's the square root of 16? 4. The square root of 9 is 3. If we add those together, we get 7. And if we subtract those, we get 1, right? What is 7 times 1? Okay, let's try it down here. What's the square root of 36? 6. The square root of 25? 5. Okay. If we add those together, and then we go, oh, I'm going to take the same two numbers, the square roots, and subtract them, I get 11 times 1, which is the answer, again. Now here's another one. Square root of 81 is what? 9. Square root of 49? 7. I can go like this, 9 plus 7. And then I can go to take the same two square roots and go 9 minus, put a plus between one, put a minus between the other one. Well, 9 plus 7 is 16, multiplied by 9 minus 7, which is 2, well, I'll be. And at some point in the past, somebody went, wait a minute, this works every time. Let's make it into an algebraic, something for kids to memorize and be miserable about hundreds of years from now. And they did. Okay, well, this is how we do it. The difference of two squares looks like this. You'll take each one of these. First off, you need to make sure. The difference of two squares means there are two squares sitting here in an expression. All right, so both of them need to be squares. The second thing, it needs to be a difference, a subtraction problem. Addition won't work, just subtraction. Okay, so what you will do is, when you see two squares, you go, wait, is y squared a square of something? Yeah, of y. Okay, is 4x squared a square of something? Yeah, well, 4 is the square of 2, X squared is the square of x. Oh, it's 2x, okay? All you'll do is find the square root of this, and then the square root of that, and write them both twice. So you'll go, okay, I got a 2x, write it twice, and write a y twice. And then between one of them, there's a plus, and between the other, there's a minus. Remember the conjugate we did the very first slide today? That's all you're doing, okay? We're just recognizing that this is true. In other words, we're going backwards. A minute ago, we multiplied those conjugates together, and we went, hey, look, the middle terms cancel out. There's just these two terms left. All we're doing is going backwards. We're taking these two terms, and we're factoring them into two conjugates, basically. That's the difference of two squares. So let's go to the right. If you remember a few minutes ago, we ended up with this, okay? All you need to do is go, okay, what's the square root of 16? 4. Okay, what's the square root of 9? Oh, excuse me, the square root of a squared is just a. The square root of 9 is 3. The square root of b squared is b. So just write that once and put a plus there, and write exactly the same thing and put a minus there. And if you wanted to check this out and multiply them through again, you'd get the middle two terms canceling out. The only thing you have left is the beginning and the ending term. And that's it. All right, take a look at the bottom left one. You tell me, what should the first term be? Don't say 50. The square root of 100 is 10. And then the square root of x squared, there you go. We can put a plus now. Square root of 49, 7. And then square root of y squared is y, right? And all we need to do is write the exact same thing again with the opposite sign. And there we go. This one right here, what's the first term going to be? 4a, right? Okay. We'll do a plus. Then square root of 64 is 8. And then b, right? Once you know that one, the other one's really easy. 4a minus 8b. That's it. There you go. That's all there is to it. Okay. Now we can use this not just to factor and go, okay, we're done. We've factored it. Now we can use this to actually solve an equation by factoring. Okay. Well, piece of cake. All we need to do is take a look at this part. Ignore that equals 0. We'll get to that in a second. Look at that and say, is that a difference of two squares? Well, that's a square of 3. That's a square of 2. That's the square of x. We got it. So let's just rewrite it. The square root of 4 is 2. X squared is x. The square root of 9 is 3. So we'll write 2x plus 3. And then we'll write 2x minus 3. Okay? And that equals 0. You know how to set this up, right? So 2x plus 3, this first one, is equal to 0. And the 2x minus 3 is equal to 0. So 2x is equal to negative 3. So x is negative 3 halves. And then you'll move this over and go 2x is equal to positive 3. So x is equal to positive 3 halves. And there you go. There's your two answers. Piece of cake. Okay. All right. That's basically what we're doing with that. Okay. Solve this by factoring. Go ahead, pause it, and see if you can pull out the two binomials multiplied by each other out of 81m squared and 25. So go ahead and pause it and try it. All right, well, let's do it. We got it. 81 squared is 9. M squared would be m. Then we'll have our plus, and of course 25 is 5. And then exactly the same thing with a minus there. There we go. Equals 0. So we have two equations. 9m plus 5 is equal to 0. 9m minus 5 is equal to 0. Really, if you have two like this that look exactly the same, just do one of them, you know? Like do 9m is equal to minus 5. So m is equal to negative 5/9. You don't have to do this all over. Just write positive 5/9. You know it's going to be the same thing except for the sign. There you go. That's all there is to it. Okay. All right. Let's look at parallelogram stuff very quickly. We're just going to get right to this. We're going to knock over the proof and just go to the actual stuff. What does a parallelogram have? Opposite blank and opposite blank are congruent. What two things? Opposite sides and opposite angles. Remember that? Okay, any two adjacent angles of a parallelogram equal 179. No, it's not. It's 180 degrees. Okay, diagonals speak tenderly to each other. Okay, no, they nurture each other. No, they don't. They bisect each other. Okay, just making sure you remember those things. All right, let's look at rhombuses. Rhombuses. Now, you write this down as a rhombus. Again, Here's your notebook, here's your notes, boom, 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 there's 39, and here we go, a rhombus. A rhombus is a parallelogram, which means the opposite sides are congruent, the opposite angles are congruent, the opposite sides are parallel, and so on. And the difference about a rhombus is that all four of the sides are equal. They're all equal, okay? So in other words, is this a quadrilateral? Yes, it is. Is it a parallelogram? Yes, it is, because the opposite sides are parallel. Do each of these have equal sides? Let's say it's a square. Then yes, the square is also a rhombus then. Of course, a rhombus can be kind of at an angle as well, right? It can be like this. Now, it won't be like this. That's not going to be that bottom is horrific anyway. Imagine it's straighter. That's not going to be a rhombus because all the side lengths are not the same. But if you see something like this, and I'll try to do this as best I can. Well, anyway, just imagine all four of those sides are the same. If it's, kind of like that, it's okay. So sides are equal. The diagonals bisect, not the sides, but the angle. Well, they do bisect the sides, but they also bisect the angles, okay? So in other words, everything that applies to parallelograms applies to a rhombus. Two angles next to each other add up to 180. The diagonals bisect each other. Also, the diagonals bisect the angles because of the side lengths. So in other words, there's a diagonal. If it bisects, then that means this angle here will be congruent to this angle right there. Okay. Second thing is the diagonals are perpendicular bisectors. In other words, if you have this and this, if I were to draw it right, this would give you a 90-degree angle because they perpendicularly, that's an adverb, they bisect each other. Okay, so let's do an actual problem they'll give you. Here's your rhombus, DEFG. Reflex angle here is 280 degrees. In other words, this angle from here to here is 280. All right, find AX, BK, C, and I don't know, any other letters you can find up there too. Okay, so this is 280 all the way to here. You tell me, what is the rest of the angle going to be? A circle is 360, right? So 360 minus 280 is 80. Since this is a rhombus, that tells us that these diagonals bisect the angle. So X and A are both exactly half of 80 degrees. So X, I'll just write it down here. X is 40 and A is 40. We there? Okay, B, well, let's see what this is. If X and A are 80 degrees, then this is a parallelogram, of course, as well. What is the measure of this whole angle right there if right next to it is an 80-degree angle? It's going to be 100, right? So K and B are both half of 100, so they're 50. Okay, C, well, we know since this is a rhombus, the diagonals are not only bisectors of each other, they are perpendicular bisectors of each other, which makes C perpendicular. That's going to be a right angle, 90 degrees, and there you go. Okay, all right, go ahead and try A, pause it and give it a whirl. Okay, well, immediately you should say, okay, the square root of 144 is 12, the square root of x squared is x, the square root of 36 is 6, so we got, oops, that should be, should that be something else? Let me pause this real quick, hold on. Okay, I didn't need that x there at all, so, okay. That'll just be a 6, and this will be exactly the same thing, 12x minus 6 is equal to 0, boom, okay. So these are two equations, 12x plus 6, oops, equals 0, 12x minus 6 equals 0. And again, you can just do one of these and go 12x is equal to 6. X is equal to 6 over 12, which is just 1/2. And of course, you know the other one is going to be negative 1/2. There you go. Okay. Okay, pause it and try B. Okie doke. Well, let's do it again. Square root of 121 is 11. M squared, M. 64 is 8. So 11m plus 8. 11m minus 8 equals 0. So let's just do, again, one of these and just kind of double up on it. 11m plus 8 is equal to 0. That means 11m is equal to negative 8. So m is equal to negative 8 over 11. And of course, the other one will be true, positive 8 over 11 as well. Okay. All right. Give C a whirl. Go ahead and pause that and give it a shot. All right. If the measure of the reflex angle is 306, The entire thing is 360. Minus 306 is 54. So x plus b will be 54, which means x will be 54 divided by 2, which is 27. B is going to be also 27. Since this is 54 degrees, this angle here will be 180 degrees minus 54. That's going to be 126. Okay. If this is a rhombus, that means the diagonals bisect the angle measure, which means the angle A is going to be half of 126 or 63 degrees. Z, again, this is a perpendicular bisector by definition with a rhombus, so Z is going to be 90 degrees by definition. So that's it. Okay. All right, you guys have a great rest of the day and have fun with those problems today. See you next time.